In this video, we're going to look at an example of how to balance a redox reaction that includes complex polyatomic ions in a basic solution. And we're going to do this through the half reaction method. Okay, so we have our example reaction here. It's bromide ions reacting with permanganate ions to form manganese 3 oxide and bromate ions. So our first step is going to be to divide this reaction into its two half reactions. So one of our half reactions will involve the manganese species, and the other half reaction will involve the bromine species. So I'm going to write both down on the page, and we're going to kind of balance them both simultaneously. So we'll start with the manganese. So that's our stem of a half reaction for the manganese, and there's lots of work to do to balance this. Next, we're going to balance our bromine, or write our half reaction for bromine, which is a little bit simpler. Br minus to bromate. Okay, step 1 complete. So our next step is going to be to balance any elements except for hydrogen and oxygen in our half reaction. So in our manganese half reaction, we have 1 manganese in our reactants, and we have 2 manganese in our product. So we're going to put a 2 in front of permanganate to balance out our manganese. In our second half reaction, we have 1 bromine in the reactants, and we have 1 bromine in the products. So no need to put any coefficients to balance bromine. Our next step is going to be to balance our oxygen atoms by adding water to the half reactions. So start with our manganese half reactions. So we have 8 oxygen on our reactant side, 4 from each permanganate, and we have 3 oxygen on the product side. And so we're going to have to add 5 waters, because each water has 1 oxygen, to balance out our oxygens. From our bromine half reaction, we have no oxygen on the reactant side, so we just have a bromide ion, and we have 3 oxygen on our product side from bromate. So we're going to add 3 water to the reactant side. Step 4, we're going to balance hydrogens. Now, although this isn't a basic environment, we're still going to add hydrogen ions, and then we'll take care of that part of the reaction at the end. So we are going to first start with our manganese half reaction. We have 0 hydrogen in our reactant side, and we have 10 hydrogen in the product from the water that we added in the last step. So that's going to give us 10 H plus ions. For our bromine half reaction, we have 6 hydrogen in our reactants from the 3 water we added, and we have 0 hydrogen in the product. And so we're going to add 6 hydrogens to the product here. In our next step, we are going to balance charge by adding electrons. So we'll start again with our manganese reaction. The charge on our reactant side is positive 10 from the hydrogen and negative 2 from the permanganate. So overall we have positive 8. And our overall charge on the product side is 0 because both of our species are neutral. In our bromine half reaction, we have a charge of minus 1 on our reactant side from the bromide ion, and negative 1 and positive 6 gives us negative 5. Positive 5 on our product side. And we're always going to add electrons to the more positive side because electrons have a negative charge. So we're going to add 8 electrons to our manganese. Now we have an overall charge of 0, which matches this charge of 0. And we're going to add 5 electrons to our product nope, 6 electrons. 6 electrons to our product here, because now we have an overall charge of -1 to match this overall charge of -1. So we have balanced our two half reactions. And so we're going to move on to step 6, which is balancing them against each other. All right, so step 6, we are balancing the two half reactions against each other. What that means is that the number of electrons that are lost in our oxidation half reaction have to equal the number of electrons that are gained in our reduction half reaction. We can't lose electrons and we can't gain electrons out of nowhere. And so we're going to multiply to find the lowest common multiple. Between 6 and 8, that's going to be 24. So we're going to multiply the bottom reaction by 4, and we're going to multiply the top reaction by 3. So I'm going to rewrite these reactions now with our multiplication. So we'll have 24 electrons gained plus 30 hydrogen ions, 6 permanganate ions, 3 manganese 3 oxide, and 15 water molecules. And we can see that this is still a balanced reaction. We have 6 manganese on both sides of our reaction, 30 hydrogens, and 24 oxygens, as well as a balanced charge. So multiplying by that whole number doesn't really do anything to the reaction aside from set us up for the next step. We're going to do the same thing to our oxidation reaction on the bottom here. So we're multiplying by 4. So we're going to have 12 water molecules and 4 bromide ions as our reactants, 4 bromate ions, and 24 hydrogens and 24 electrons as our products. And again, we can check that this is still balanced. We have a total of 24 hydrogens, 12 oxygens, 4 bromines, and an overall charge on both sides of -4. All right, so now we're going to add these two half reactions together, and I'm just going to highlight redundant species here so we can cancel them. So electrons will always cancel. 24 electrons and 24 electrons. So there will be no electrons in our net reaction. We can cancel out hydrogens, so not all of the hydrogens. We have 24 hydrogens here in our second reaction and 30 in our first reaction. So what we're going to be able to cancel out is all 24 in the oxidation reaction and all but 6 in the reduction reaction. And the last redundant species that we can cancel out here is our waters. So we have 15 water in our reduction reaction and 12 waters in our oxidation reaction. So we can cancel all 12 in the oxidation reaction and all but 3 in the reduction. And that's going to give us an overall or a net reaction at this point of, I'm going to write it a little bit bigger here. So we'll have 6 hydrogen ions, 6 permanganate ions, 4 bromide ions. Those are our reactants. Our products will be 4 bromate ions plus 3 manganese 3 oxide and 3 water. And we can check that this is balanced still just to be safe. So we have 6 hydrogens total. We have a total of 24 oxygens, which is divided up into 3 compounds on our product side. So 12, 9 is 11. Nope, 12 plus 9 is 21, plus 3 is 24. Sorry. 6 manganese and 4 bromines on both sides. So we're all balanced here, and that brings us to our last step. So this reaction is still has hydrogen ions present, but it's supposed to be balanced in base. So we need to do something to take care of that. Our final step in this balancing reaction is to get rid of the hydrogens by reacting them with hydroxide. So we're going to take our reaction that is already balanced, and we are going to add hydroxide ions to both sides of this reaction. And the reason we want to add it to both sides is because it's already balanced. What we do to one side, we have to do to the other if we want to keep it balanced, which we do. We did all of that work. So we're going to add 6 hydroxides to both sides. And the reason that we do this is that when hydrogen ions and hydroxide ions react, they form water, thereby neutralizing the hydrogen ions that were present. We'll end up with an excess of hydroxide ions on the opposite side of the reaction. Now the 6 water molecules we formed here can actually cancel out. Three of them will cancel with the water molecules on our product side. So it's basically switching where the water is in the reaction. So our overall balanced reaction will actually be 3 water on our reactant side, 6 permanganate, 4 bromide, to form 4 bromate, 3 manganese 3 oxide, and 6 hydroxide ions. And we can verify that this is in fact fully balanced before we call it done by counting the elements on both sides of the reaction. So on our reactant side, we have 6 manganese from our permanganate. We have 4 bromide, or 4 bromine from the bromide ions. We have a total of 3 plus 24, so 27 oxygens. And a total of 6 hydrogens from the water molecules. If we look at our product side, we have 6 manganese, from our manganese 3 oxide. We have 4 bromine from our bromate. We have 4 times 3 is 12. 3 times 3 is 9, so 12 plus 9 is 21, plus 6 is 27 oxygen. And we have 6 hydrogen from our hydroxide. We can double check the charge is also balanced. We have a total of 6 times -1, so -6 plus -4. So a grand total of -10 on our reactant side. And on our product side, -4 from the bromate, -6 from the hydroxide, so also -10. And so we've balanced this complex redox reaction in a basic solution using the half reaction method.